Right now, 628 million kilometers from Earth, there's a moon being torn apart. Its surface rises and falls by 100 meters every 42 hours, like clockwork. 400 volcanoes blast lava 500 kilometers into space. The ground glows at 1,600 degrees Celsius, while the air freezes at minus 143. And every million years, the entire surface gets recycled, erased, reborn in fire. This is Io. And what's happening there breaks every rule we thought we knew about moons. In 1979, Voyager 1 approached Jupiter expecting to photograph dead, cratered moons. Standard procedure, nothing exciting. Then navigation engineer Linda Morabito noticed something in the images that shouldn't exist. A massive umbrella-shaped plume extending 300 kilometers above Io's surface. She checked the data again, then again. It wasn't a malfunction. It was a volcano. Erupting, active, now. Scientists were stunned. In the frozen outer solar system, where temperatures plunged to unimaginable depths, they'd found a world more volcanically active than Earth. Not just a little more active. Io had more active volcanoes than all other planets and moons in the solar system combined. But here's what made it truly bizarre. Io's sister moons, Europa, Ganymede, Callisto, were all covered in thick ice, frozen solid, dead for billions of years. Yet Io, orbiting at roughly the same distance from the sun, was exploding with volcanic fury. Something wasn't just heating Io, something was torturing it. The culprit is Jupiter itself, but not in the way you'd think. Jupiter is a monster. It contains more mass than every other planet in the solar system combined. Its gravitational pull is so immense that it warps everything around it, and Io orbits just 421,000 kilometers away from this giant, closer than any other large moon. That proximity should be enough to generate some tidal heating, but Io isn't suffering from simple tidal forces. It's caught in a gravitational torture chamber. Here's what's happening. Europa and Ganymede, Jupiter's other large moons, are locked with Io in what's called orbital resonance. For every orbit Ganymede completes, Europa completes 2, and Io completes 4. This cosmic clockwork means that these moons line up in the same configuration over and over again, amplifying their gravitational effects on each other. The result? Io gets pulled into an elliptical orbit. As it swings closer to Jupiter, gravity intensifies. As it swings farther away, gravity weakens, but it never gets a break because Europa and Ganymede keep yanking it back into that elliptical path. So Io is constantly being squeezed, stretched, compressed, deformed. The entire moon flexes by up to 100 meters with each orbit. Imagine Earth's surface rising and falling by the height of a 30-story building twice a day. That's what Io endures every 42 hours. This constant flexing generates heat. Enormous amounts of heat. Io produces roughly 2.5 watts per square meter of surface. Across the entire moon, that's 100 trillion watts of heat, 200 times more than all of Earth's volcanoes produce combined. That heat has to go somewhere, and it does, violently. The surface of Io looks like something from a fever dream. Yellow and white plains stretch for hundreds of kilometers, frozen sulfur dioxide snow that erupted from volcanoes and fell back to the surface in the freezing vacuum of space. Red and orange patches glow with active lava flows, some reaching temperatures over 1,600 degrees Celsius. Black scars mark recent eruptions, and scattered across this alien landscape are up to 400 active volcanoes, each one reshaping the surface in real time. Some of these eruptions are explosive, hurling material 500 kilometers into space. That's higher than the International Space Station orbits Earth. The material then rains back down, burying older features under fresh volcanic deposits. Other eruptions are more continuous, feeding massive lava lakes that boil and churn for years at a time. The largest of these lakes, Loki Patera, spans over 200 kilometers. That's bigger than the entire state of Connecticut. And it's not a lake of water, it's molten rock, constantly recycling as cooled crust sinks and fresh magma wells up from below. But here's what's truly strange about Io's volcanism. It doesn't build mountains. At least, not volcanic mountains. On Earth, repeated eruptions pile up over time, creating towering volcanic peaks like Mount Fuji or Kilimanjaro. Io's volcanoes don't work that way. Instead, the lava spreads out, filling in low areas and creating those massive lava lakes. The constant resurfacing means nothing has time to build up, yet Io does have mountains. Tall ones, isolated peaks that thrust dramatically upward from the surrounding plains. And they're not volcanoes at all. Take Steeple Mountain. This peak rises sharply from Io's surface, but there's no volcanic vent, no lava flows radiating outward. Scientists believe these mountains form through a completely different mechanism. As volcanic material continuously buries the surface, older rock gets compressed under immense weight. Eventually, that compressed rock can't take the pressure anymore. It buckles, it fractures, and sections thrust violently upward, creating these isolated peaks. So while volcanoes are tearing Io's surface apart, the weight of all that volcanic material is simultaneously creating mountains through sheer compression. It's geology on fast forward, and the entire surface gets completely recycled every million years. For decades after Voyager, we had to watch Io from a distance. Galileo spacecraft gave us more details in the 1990s and early 2000s, but it still wasn't enough. Then, in December 2023 and February 2024, NASA's Juno spacecraft dove closer to Io than any probe had ventured in over 20 years, just 1,500 kilometers above the surface. The images Juno sent back revealed Io in unprecedented detail. Individual volcanic vents, active eruptions caught in the act, lava flows spreading across the surface. And when scientists compared these new images to older ones from Voyager and Galileo, they saw something remarkable. Entire regions had been completely resurfaced. Features that existed just decades ago were gone, buried under fresh volcanic deposits. Lakes had changed shape. New volcanoes had appeared. Old ones had vanished. Io wasn't just active. It was being remade constantly, right before our eyes. Juno also measured Io's gravitational field with incredible precision, confirming what scientists had long suspected. Beneath that tortured surface lies a global magma ocean, not pockets of molten rock, an ocean. Io is quite literally a shell of rock and metal wrapped around a sea of liquid magma. Io does have an atmosphere. Calling it that is generous. It's about 1 billion times thinner than Earth's and made primarily of sulfur dioxide gas, the same stuff erupting from those volcanoes. But as soon as the gas reaches the surface, Jupiter's powerful magnetic field strips it away molecule by molecule. That stripped material forms a massive torus of charged particles around Jupiter, the Io plasma torus. This glowing donut of superheated ions is so energetic that it affects Jupiter's entire magnetosphere and creates auroras at Jupiter's poles. And if the volcanic eruptions weren't deadly enough, Io sits directly in the middle of Jupiter's radiation belts. Any spacecraft that ventures close gets bombarded with radiation thousands of times more intense than what would be fatal to humans. Even our most advanced electronics can only survive brief visits before getting fried. This is why studying Io is so difficult. It's not just that it's far away, it's actively hostile to anything we send there. Let's be clear about how extreme Io really is. Earth has maybe 50 to 70 volcanoes erupting at any given time. Io has 400. Earth's most active volcano, Kilauea, erupted continuously for 35 years. Io has volcanoes that have been erupting for decades and show no signs of stopping. Earth's volcanic activity releases heat slowly over millions of years. Io's entire surface gets recycled every million years. Even compared to other volcanic worlds, Io stands alone. Venus might have recent volcanic activity, but it's sporadic and localized. Mars has the largest volcano in the solar system by volume, Olympus Mons, but it's been dead for millions of years. Saturn's moon Enceladus and Neptune's moon Triton have cryovolcanoes that erupt water and ice. Impressive, but those are cold geysers compared to Io's infernos. Io generates more heat per square meter than any other solid body we've ever found. It's the only moon with active silicate volcanism, and it's the only world where tidal forces alone generate enough heat to maintain a global magma ocean. Despite everything we've learned, Io remains deeply mysterious. We still don't fully understand the structure of Io's interior. How deep is that magma? Ocean? Where exactly is the heat being generated? The tidal heating models work, but the details are fuzzy. Why are some volcanoes vastly more active than others? What determines where eruptions occur? The surface changes so rapidly that every time we visit, we see something completely new. What drives these patterns? Why do some regions stay relatively stable while others are in constant flux? And the interaction between Io, Jupiter's magnetic field, and the plasma torus is extraordinarily complex. We're still piecing together how this system works and how it feeds back into Io's volcanic activity. There's so much we don't know. And here's the frustrating part. We might not get answers anytime soon. Juno's mission is ending. In 2025, the spacecraft will be intentionally crashed into Jupiter to prevent any possibility of contaminating Europa with Earth microbes. NASA's Europa Clipper launched in 2024 and will arrive in 2030. The European Space Agency's JUICE mission will arrive around the same time. Both missions are focused on Europa, Ganymede, and Callisto, the icy moons, the places where subsurface oceans might harbor life. Io? Io isn't part of the plan. There have been proposals for dedicated Io missions. The Io Volcano Observer would make repeated close flybys, mapping the volcanoes in exquisite detail and measuring the tidal forces in real time. It would answer fundamental questions about how tidal heating works and how volcanic systems evolve on other worlds. But funding is limited. Priorities lie elsewhere. The search for life takes precedence. So Io, the most volcanically active world in the solar system, a moon that defies everything we thought we knew about geology, a laboratory for understanding tidal forces and planetary interiors, will continue erupting, changing, evolving, largely unwatched. Io is a world where the ground rises and falls by 100 meters every 42 hours, where 400 volcanoes erupt simultaneously, where temperatures swing from minus 143 to over 1,600 degrees Celsius, where sulfur snow falls from the sky and lava lakes boil for decades, where mountains thrust upward not from volcanic activity but from the sheer weight of volcanic deposits crushing the crust below. It's a reminder that the universe contains places utterly alien to our experience, places shaped by forces we can barely comprehend, places that challenge our understanding of what a world can be. Io doesn't harbor life. It probably never will. But it shows us something equally valuable, the incredible diversity of worlds that exist in our cosmic neighborhood. It expands what we think is possible. It forces us to rethink our models. It proves that even in the cold, dark, outer reaches of the solar system, there are worlds burning with fury, and it will keep burning, long after we stop watching. Long after our spacecraft have moved on to other targets, Io will keep erupting, keep reshaping itself, keep putting on the greatest volcanic show in and the solar system. Because caught between Jupiter's crushing gravity and the relentless pull of its sister moons, Io has no choice. It's trapped in an endless cycle of destruction and creation, and that cycle won't end for billions of years. Should we send a mission back to Io, or should we focus on the search for life elsewhere in the solar system? Drop your thoughts in the comments, and if you want to see more about the most extreme places in space, hit that subscribe button.